Right, welcome to talk number 6, which is about a theory of physics called energy wave theory. That's what its author calls it. So this is leading on from the last talk. A quick recap of the last talk is maybe the ether does exist. So we looked at the Michelson-Morley experiment where they tried to detect the ether, failed to do so, and then some other people redid the maths later and said, actually, the ether could exist. The experiment doesn't really prove anything either way. So this theory is by a guy called Jeffy Yee. He calls it energy wave theory, and it essentially is based on the idea of everything being waves in the ether. I find like parts of it really compelling, and parts of it I'm like, that looks quite suspect. I think maybe what I should have written on this slide was, I think that if there is going to be a more unified theory of everything, it will probably look something along these lines. I think this theory is quite a long way off, like solving a lot of stuff yet, and there are bits of it where I'm like, oh, I don't think that adds up. But I think like the broad concepts and the overall approach, I think is quite cool. So I'll kind of go through it. I'll explain it, or explain the sort of beginnings of it in a way that's kind of how I think he explains it, or my understanding of his explanations. But there will be a couple of bits where I will say, I'm not quite sure about this, but I would explain his take on things. So the starting point of this theory, as I mentioned, is just that the ether does exist, the invisible universe jelly that fills all of space. And the theory says that this is the only thing that exists, that everything, light and matter, is all just vibrations of the ether. So it is in that sense, a unified theory, or it will be when it can explain everything. So that's the basis of this theory. Everything is just vibrations in the ether. If you're going to summarize the entire theory in one slide, it's this: that matter is made up of essentially expanding and contracting like bubbles, sort of like growing and shrinking beach balls of the ether, spherical vibrations, and that then light is a transverse wave that's just a vibration traveling through the ether. So as we talked about with electromagnetism and the idea that possibly everything is electromagnetism, this theory says matter is confined energy in a standing wave and light is unconfined energy that's traveling. Stuff about waves. Yes. So just some terminology. So transverse wave, meaning that the displacement is at right angles to the direction in which the wave is traveling, and longitudinal waves where the displacement is in the same direction that the wave is traveling. So this is sort of animation of an acoustic monopole, or basically a wave traveling outwards from a central point. So this is a longitudinal wave, and I think this is quite good in firstly helping you to see how difficult it is to represent longitudinal waves, because the displacement is in the same direction as the direction of travel. So you can see, if you, these red dots on here are just basically moving with one particular particle. So this representing a sound wave, all the particles are representing air molecules, and the red dots are basically just tracking individual particles, so you can see what's happening to them. And you will notice that near the center, this red dot is moving quite a long way, so it's displacement or its amplitude is about the same as the wavelength of the wave. But as you get out over on the left and you've got that red dot there, the displacement is very small. But as you can see from the general rings, the wavelength is still the same. So you get this reducing amplitude the further you get from the center. This is in 2 dimensions, but ether wave theory says that these vibrations are in 3 dimensions. So they are spherical longitudinal waves contracting and expanding bits of the ether. And crucially, the amplitude of those vibrations will reduce with the square of the distance from the center. And that will sort of become a bit more crucial later. Oh, look, I put labels on. I even wrote things, which is just what I have said. So the next thing to talk about is the idea of standing waves. So I hope no one's colorblind because this uses red and green. So the green wave is traveling right to left, and the red wave is traveling left to right. And those 2 waves are traveling at the same speed and they have the same wavelength. Therefore, they also have the same frequency. And so when you have 2 waves traveling in opposite directions, the resulting wave is a standing wave which stands still. So the blue wave is the resultant wave from the red and the green, and that result being a wave that has displacement, but it doesn't have any movement. It doesn't go anywhere. And that means that you get some points on the wave called nodes, which don't have any displacement at all. And that is a crucial feature of this theory, that when you have standing waves, there are some points on those waves with 0 displacement. And I suppose this is kind of what you get on a guitar string. If you were to pluck a guitar string, essentially you've got a wave traveling from the neck of the guitar, sorry, the head of the guitar down the neck to the bridge, and you've got another wave traveling from the bridge along the neck of the guitar in the other direction up to the head, and those waves are effectively reflecting off each end of the guitar and coming back the other way, and the result is that you just get the string just sort of vibrates back and forth. And if the guitar string wasn't losing any energy in the form of sound, then it would just sort of vibrate forever. Obviously it does lose energy, which is why you can hear it, but essentially standing waves just stand there. So the theory says that matter is a longitudinal spherical standing wave, meaning there is an inward wave coming in to the center of a particle, and there is an outward wave of the same frequency and the same amplitude traveling outwards. And then the result that you can see on the right is just a standing wave which doesn't go anywhere. Obviously, this is represented in 2 dimensions because it's just incredibly hard to visualize or to sort of animate in 3 dimensions. Hopefully this gives a good idea of the concept. This animation on the right, I think if you were viewing it perfectly top down, which obviously you're not, but if you were, I think there would be some pixels on there which were just staying the same color, that were not changing at all, because the pressure would be constant, because they would be nodes on the standing wave. And that means, yeah, you get these nodes on the standing wave, but the nodes are spheres. They are distances from the center at which no displacement happens. And that then becomes crucial in a bit. So the theory says that each particle, or each fundamental particle, is one of these contracting and expanding beach balls, one of these standing waves. And therefore, because you've got these nodes at certain distances from the center, it then says that these waves, or these particles, can kind of sit next to each other at certain distances and will then want to stay there. This then kind of gets into the idea of a wave center, which is something that comes up in this theory. And the way I imagine this is that the center of one of these particles must be stationary, because it's always either being squashed equally from all directions by the incoming wave, or it's being stretched equally outwards in all directions by the outgoing wave. And therefore the center is a point of zero displacement, I think, which very much wants to be a point of zero displacement, because it's sort of the point in the particle which is most strongly held in one place. And therefore the wave center of one particle always wants to sit itself on a node of another particle, so that it is set at a zero displacement point. So the theory says that. To then align the theory with current general physics theory, it then says that basically everything is built from the neutrino. So this is our array of particles with the pictures from Particle Zoo. And this theory says that the neutrino is the building block of everything, and that all other matter particles are constructions of neutrinos. So here's our little neutrino chap. At some radius from the center, there is a node of zero displacement, which means that you can then sit another neutrino on that node. That neutrino also has a node at some radius. They sit on each other's nodes, but then there's also another node where those two nodes cross over, where you can stick a third neutrino. So you can have this set of three, and that they will want to stick together in this triangle formation. But those rings are actually spheres, and therefore there is actually a fourth location behind it in space, as it were. So this is actually a tetrahedron. There are four neutrinos which want to stick together in this three-dimensional shape. And it's from the building up of these three-dimensional shapes that the theory says all other particles are derived. There we go. There's an equally bad picture of that idea. So it says we have these tetrahedrons of neutrinos. And so obviously the first level at the top is just one neutrino. Then you can add another three to get a tetrahedron of four. And you keep on adding layers in triangular numbers. According to the theory, the electron is a tetrahedron of 10. And it says that this is essentially the most stable combination of neutrinos. This is where I disagree slightly, because I think that the just four, the two-level version, would be more stable than the 10 version. But according to the theory, the electron is made up of 10 neutrinos, and that these stick together so well due to sitting on each other's nodes that the electron appears to be a fundamental particle, because it requires so much energy to break them apart that essentially we never manage to break them apart. So the electron appears to be fundamental, but actually the only fundamental particle is the neutrino. The theory then makes parallels with chemistry and with atomic nuclei. Atomic nuclei are made up of spheres, well, probably not spheres, but protons and neutrons stuck together in lumps. And if you look at the sort of patterns of stable nuclei, there are some patterns of sort of magic numbers which do seem to correlate to the tetrahedron numbers. So the theory says that atomic nuclei may well be arranged in tetrahedron-like structures. There's an obvious complication here in that atomic nuclei have protons and neutrons, and therefore it's not going to be quite straightforward, or they're not going to map exactly. But the theory draws that parallel. So like in chemistry, we have the periodic table of the elements, and obviously the number of protons just increases by 1 with each element, but the number of neutrons increases in a slightly odd order because the number of neutrons which make a stable structure in the nucleus doesn't just increase by 1. They seem to go in these sort of odd magic numbers. So energy wave theory creates a periodic table of the particles, which is the same concept, but with everything just made of neutrinos. I still haven't like fully interrogated this to see quite how much I agree with it, because neutrinos don't have charge. We'll get onto that in a bit. But I'm not sure exactly how much you can draw parallels between the two, given that atomic nuclei have protons and neutrons, whereas this is talking about just a single type of particle, the neutrino. But there are some cool graphs that map some of these numbers together. There are some parallels with the magic numbers on the face of it. Some of this is quite cool. That is stuff I've already said. So the theory then goes on to say that because the electron appears to be a sort of particle on its own with this very stable structure of 10 neutrinos, it then says you can kind of do the same thing again, and you can make composite particles out of electrons. And it essentially says that the proton and the neutron are made up of putting electrons together in various ways. And that gets into a complication about charge. That's one of my bits of skepticism, but we'll get to that in a moment. So one thing that I think is quite nice about the theory is, firstly, its simplicity, that everything's made from the ether. The ether creates neutrinos, and you can then build things out of those. And that it has this idea of essentially nature repeating itself quite a lot. It's not an exact repetition at each level, but that there are similarities in the way that the different levels of matter are made up. So this is one part of the theory. Another part of the theory that I'm not entirely sure about, but if you accept it, then some cool stuff happens. And it's this idea that at the radius of the particle, so this particle has its waves. If you combined 10 neutrinos, you've sort of got, essentially you've amplified the waves by sticking them together. And it says that those combined waves then have essentially a boundary, which is the effective radius of the particle. And that at that boundary, the standing waves transition into traveling waves. I've got a better picture of this. Yes. So it says this. You've got the actual center of the particle with the tetrahedron of neutrinos. There are in waves and out waves, creating this sort of standing wave which goes out to the radius of the particle, which is bigger than that tetrahedron in the middle, and that then at this magic radius, the standing wave ceases to be a standing wave, and you then get traveling waves going out. Now, this raises questions like, where did the traveling wave go? Is the particle losing energy? And there are vague answers like, well, there are other particles everywhere, so there are incoming waves from other particles, which I find hard to buy. But if we accept that a particle is this standing wave and that beyond its radius there is a traveling wave going out, we then get onto the idea of charge. But before we do, we have a great cartoon, which I couldn't resist putting in. And it's so one idea of ether or energy wave theory is that the ether is always trying to move to minimize its displacement. And I guess this could be said to be the reason why a wave waves at all, which is that when you cause a displacement in the ether, it's always trying to work to minimize the displacement, and so the displacement sort of gets moved along to the next bit, and hence you get a wave or a vibration. But essentially it's the idea that the ether is elastic, and therefore if you stretch it or compress it, it's always just trying to spring back again. And so with that in mind, if we accept this idea that there are traveling waves beyond the radius of a particle, then phase difference can be used to create charge. So if you have two particles, and their waves are in phase with each other, then when those waves combine, their amplitude will increase, which is not what the ether wants it to do, and therefore those particles will repel each other. Similarly, if the waves are out of phase, then as the waves combine, they will cancel, which will reduce the displacement in the ether, which is what it wants to do. And therefore, those particles will be attracted to each other, because, of course, the closer they are to each other, the greater the amplitudes, because the amplitudes decrease with distance. And therefore, those particles want to move towards each other in order to get more cancellation and decrease the ether displacement. And of course that happens with the square of the distance, which maps to the standard equation for the force between two charged particles. Force equals k, some constant, multiplied by the charge of one particle, the charge of the second particle, multiplied together, divided by the distance between them squared. So that idea of charge being phase difference kind of maps to that. I also have a huge problem with it, which is that if those two particles moved towards each other, it would change the phase difference, and therefore particles that were originally in phase, when they became close to each other, would be out of phase, and vice versa. The theory kind of talks about the idea that because the particles themselves are waves, that they only move essentially like along nodes of other waves, and therefore their movement towards each other is not directly in a straight line, but takes a path along wave nodes, which sort of gets into stuff that's too complicated for me to follow. I'm not entirely dismissive of it, but I'm slightly skeptical of it, but it's an interesting idea. So charge decreases with square of distance, which then means you can do a bit of trickery and simplify physics slightly. So physics has these fundamental units: force, mass, distance, time, and charge. There are a few others like temperature and luminosity and things, but they're not relevant here. Essentially, physics has got these fundamental units that we measure things in, and you can't swap one of those units for another one. Or to put it better, the other things that we measure are derived units. Like speed is distance divided by time. Speed is not a fundamental thing in itself, it's just derived from fundamental units. Similar with acceleration, distance divided by time squared, and voltage is energy divided by charge. Note my mistake that energy is not in my list of fundamental units. It's not really a mistake, but energy from E equals mc squared, energy is mass times speed squared. So you can represent energy as mass times distance squared divided by time squared. So energy is a derived unit as well. Energy is not a fundamental thing. So then voltage is not a fundamental thing. And then we have some handy equations, which are essentially just more derived units. E equals mc squared we just talked about. And then force. Why have I put force as a fundamental unit? It's really not. That's a mistake. That's a real mistake. Force equals mass times acceleration. So if we say that charge is the phase difference of these longitudinal waves, or rather charge is created by the phase difference. Charge is not the phase difference itself. Charge is the distance of displacement of the ether, and that distance of displacement decreases with the distance that the particles are apart. So we can then essentially remove our charge as a fundamental unit. Voltage we've defined as energy divided by charge, but if we then swap charge for distance, because charge is actually just the amount of ether displacement, then we swap energy with E equals mc squared. There's some more distances and times in there. We can do some cancelling of some of the distance, moving some squared symbol around to squared symbols around to rearrange things, and then we get voltage equals mass times distance over time squared. Distance over time squared, as you'll note, is acceleration. So we've now got voltage equals mass times acceleration, which is the same as force. So then voltage is actually just a force. So we can then scrub from the fundamental units. We can scrub out charge, and we can scrub out voltage because it's actually the same thing as force, which should be in the other list. I kind of like that because it's a simplification of things, and I like theories that make things simpler. So despite my skepticism about the whole charge thing, I think that this is quite nice. To do a slight detour that I don't have a slide for, my alternative view of charge is that rather than there being a traveling wave that moves out from a particle, it might just be that the standing wave actually causes a net contraction or a net expansion of the ether, and therefore it's not a traveling wave going out from the particle. It's just there's just a sort of a volume of contracted or expanded ether around each particle, and that some particles can create a net contraction and other particles create a net expansion, and therefore you would get the same effect but without the need for this traveling wave stuff and without the need for the phase difference. So for this talk, one more idea from energy wave theory, which is about the double slit experiment. So I talked about this in the first talk. It's this famous experiment in which you shine light through two slits, and the light waves then diffract as they go through the slits, and those diffracted waves then interfere with each other to build up this pattern of light and dark bands on the screen that the light hits. This experiment is interesting because you still get the same interference even if you only shine one photon at a time, and you get the same pattern of interference if you fire electrons through the slits. So the electrons appear to travel through both slits at once and interfere with themselves. So energy wave theory has an interesting take on this, which I'm still yet to fully pass judgment on. So it says you take an electron, you fire that electron towards the slit, but at some time later, the electron is closer to the slit, and according to the theory, there are these traveling waves going outwards from the electron. So at the moment, just before the electron passes through the slit, its waves are traveling outwards, which means that its waves will travel through the other slit. So the electron is going to go through the bottom slit, but its waves will still go through the top slit, which means that those waves will themselves diffract, which means that when the electron then continues its journey towards the screen, it is now interfering with, or it's now experiencing this phenomenon of charge from its own earlier set of waves. And of course, those waves are traveling at the speed of light through the ether, but the waves that have gone up to the other slit and back down again have got a much longer journey, and therefore the electrons' waves can now interfere with the old versions of themselves, creating forces which will then sort of give the set of places where the electron doesn't want to go and places where the electron does want to go, thereby explaining the set of light and dark patterns on the screen without the electron ever having to actually go through two routes at once, which I think is interesting. If you want to go and dive into some of this stuff yourself, that is the YouTube channel, which contains a whole bunch of videos going through different parts of the theory. Jeff Yee's papers are on researchgate.net. And then there is a GitHub project, which is some computer emulation experiments of people trying to create like 3D models of this stuff and emulate it in order to test the theory. Next time, I will attempt to go into some of the other bits that the theory explains, including why electrons spin, what magnetism is, what gravity is, and what light is. And that is the end.